are 9 engines on the first stage, there are actually 10 engines on the vehicle as a whole. The second stage has a slightly modified engine on it. It's called the Merlin vacuum, or what we call the MVAC engine. This engine has a larger nozzle, which allows the second stage to perform more efficiently in the vacuum of space. The first stage gets us out of Earth's atmosphere and into space, while the second stage takes the payload to its targeted drop-off orbit. The large barrel structure with the pointed nose at the very top of the rocket is the payload fairing, and it's composed of 2 halves made up of carbon composite material that come together to protect the payload until we're in the vacuum of space. And speaking of the payload, the Nova-C lunar lander arrived at Kennedy Space Center in Florida back in December. Since then, teams have been integrating the spacecraft to Falcon 9's second stage in preparation for launch. And as Megan mentioned earlier, during this mission, SpaceX proved out new procedures and hardware that enabled fueling of the IM-1 lander on the pad with cryogenic methane and oxygen starting about 2.5 hours before launch. This is a first for SpaceX. SpaceX teams modified Launch Complex 39A's pad and transporter erector, installing a new liquid oxygen tank, methane tank, propellant lines, and 2 control skids on either side of the top of the transporter erector. From there, the new propellant lines pass through a new Stage 2 quick disconnect that attaches to new plumbing and another set of quick disconnects leading to the IM-1 lander. Heat exchangers within the ground system densify the oxygen and methane as they flow from their storage tanks towards the lander.
Falcon 9 tanks are venting for the startup propellant load.
This allows the cryogenics to remain below their respective boiling points during the countdown and eliminate the need to top off the propellant while Falcon 9 is being loaded for launch.
The abort instructions. For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the count. For urgent issues affecting the safety of the operation, operators shall call hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed into launch abort. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
Just pausing for those comms there. Given the lack of methane used in the Falcon program, Falcon teams leaned on the expertise of Starship teams and are using methane sensors from Starship to verify the health and status of the lander and our fueling system. And so far, it continues to be a smooth countdown, and we're looking good for an on-time liftoff. In the meantime, let's check in with Josh Marshall over at Intuitive Machines. How's it going, Josh?
It's going well, Jesse, and thank you. And welcome into the broadcast booth at Intuitive Machines' Mission Operations Center in Houston, Texas. This room is just outside of what we call Nova Control. Nova being the nerve center of our entire lunar program. Right now, flight controllers are making their pre-flight checks and monitoring our lunar lander's fueling process on the pad. Take a live look into Nova Control. There are 12 console positions in a circular design. This unique shape wasn't a coincidence. We wanted to create a collaborative environment that folks can quickly communicate and make decisions. The design also pulled some inspiration from the Star Trek USS Enterprise bridge. Starting now, we have 3 primary flight controller teams working around the clock to monitor, command, and control our lunar lander during its journey to the moon's South Pole region. Here's a closer look at how we'll get there. The Intuitive Machines IM-1 mission is sending commercial and NASA payloads to the lunar South Pole region on an uncrewed robotic Nova-C class lunar lander called Odysseus.
The lander is the tip of the iceberg, and what's below that is the full program that is on a miniature scale, very similar to what the Apollo program had.
The IM-1 flight path mirrors the historical achievements of Apollo 2. Starting with separation for the launch vehicle on a direct shot at the moon.
That trajectory is basically like throwing a fastball that is going to hit the moon 6 or 7 days later, like an outfielder stretching out to grab it.
The first 4 days are dedicated to flight controllers in Houston firing the lander's 3D printed liquid methane and liquid oxygen engine to make small course adjustments to hit its orbit target around the moon. This particular coordinate system is called the B-plane.
You can think about the B-plane kind of like the backboard of a basketball ball. And you basically know when you shoot hoops that if you can get the basketball in the square on that backboard, it's going to go in. And the B plane for astrodynamicists is very much the same thing.
With the B-plane on target, Odysseus is prepped for a critical autonomous maneuver on the moon's far side. This critical burn maneuver is completed in the blind, with the moon blocking direct communications back to Nova Control in Houston.
Once we get around the moon, we have on the day side of the moon, the sun heating us from one side and reflected infrared light off the bright moon warming us on the other. Then we plunge into night, and now we're cold on both sides. It's very tough.
About an hour before landing, flight controllers command Descent Orbit Insertion, or DOI. This is